Welcome to another episode of TimmerTech. Now, I apologize, I have been away for a while, had a lot of stuff to do in my private life, but I'm back and we dive straight in. So, in today's video, I'm going to show you how to set up an NFS provisioner, which allows us to use a share from our NFS server. Now, I'm using a Synology to provide that. So what I'm going to show you allows you to use a NAS, so you can use that to store your data of your deployments of your cluster. Now, let's dive in. I'm Garrett, and this is TimmerTech. So for this video, we need to cover several parts. Dependencies, what do we need to install on our nodes? The configuration of our NAS, so I'm going to show you how to do it with a Synology. And then we have to create our deployment and then deploy it. So these are the parts that will help you set up an NFS provisioner. Dependencies, it's not hard. So I'm running Ubuntu, so the only thing you would need for this is the NFS command package. Now, if you're using my Ansible project to set up your cluster, it's already installed. Link down below, and you can use that Ansible project I've talked about in previous videos. So when that is set up, we can go straight on configuring our Synology to use with our NFS provisioner. Now, let's dive into the configuration of our Synology. Let's jump to our Synology disk station manager, and I can show you around what you need to do. It's not hard. So here we are in our disk station manager of Synology. So the first thing you want to do is you want to enable NFS. So I'm already using this in production, so it's already activated. But you would go to File Services, then you would go to NFS, you enable NFS, you select the NFS version. I'm using NFS 4. And with advanced, you can actually set the read and write packet set. I sent this to 8 kilobyte, but you can use a lower one. But if you don't know, just set it to 8, you should be good. This will also improve speed when you're doing large files. Now, that is for enabling NFS. The next part, what you need to do is you need to ensure that your share has the right access, because access to NFS shares works on originating IP. So the originating IP is sent with the request to the NFS server, and therefore it's allowed to access certain things. Now, how you're going to do that with Synology? You're going to go to your shared folder, and in this case, I'm going to give access to NFS to the K3s folder. So you would go to your shared folder, then you go to Edit, and here you will find at the end NFS permissions. And this is the whole trick. So what you can see here is these are the IP numbers that have access to this share. Now, I have multiple nodes, so my range is a little bit bigger, and I'm using CIDR, which is the slash at the end of the IP address. And that will allow a range of IP addresses. If you're not entirely sure what to do, then you simply put in the IP number of every node you want to have it access this particular share. So what I have here is the 1010 is one of my additional networks. The 100.64 is the Tilscale network I am using. And here you will see several IP addresses of my internal network with a /30 CIDR. And that is providing the different IP addresses. So what I'm doing here is I'm giving a total range, basically saying from 20 all the way till 80. Now, then it comes to the privileges. So let me go to, for example, the Tilscale. I sent everything to read-write because we want to be able to write to these shares. You can actually use this also to create a read-only share for read-only data. But what I am doing is I'm giving everything read-write access, and within the pod, I decide if this is a read-only share. Squash means currently I'm doing no mapping. This allows you to map the incoming user to a specific user of Synology. For example, map when somebody is accessing as the root user, say you have a root user in the deployment in your pod on your cluster, then this will cause it to be mapped to the admin user of your Synology. So when you would see file permissions on your Synology, you would actually see that it's owned by admin. I am doing no mapping, which means that it will show on my Synology with weird users. And that's actually the user IDs being used in the cluster, in the pod itself. Now, I'm also using enable asynchronous communication, which means that, yes, there is a risk for me of losing data. Synchronous, if you turn this off, that would mean that every read-write has to be completed before your application continues. Important that you allow ports from non-privileged ports for higher than 1024. And the most important part is allow users to access mounted subfolders. Now, what we're going to do later on in this video, we're going to deploy the NFS Subdir Provisioner, and that allows us to mount subdirectories. So what I'm doing is I'm providing a single share K3s for my cluster, and this allows me to map multiple subdirectories of this shared folder on my Synology to a particular deployment. So I can create a folder for a certain application, create another one, and then that subdirectory in the share will be able to be mounted by the deployment. That's why you really need that. So simply put in the IP address of your nodes and you're good to go. Now, let's build our deployment. So for our deployment, I am using the repository we have used in previous videos. You will find the NFS provisioner in the folder NFS. The one thing I would like to show you here is I also include a README file that will tell you how to install the required dependency for each node if you are not using my Ansible playbook of setting up your cluster. So just install for, in this case, Ubuntu. You would install the NFS command package, and that allows you to use NFS. Now, the NFS provisioner can also provide you with volumes in the way of a persistent volume claim, like with Longhorn or similar storage layers. That is possible, but I am not going to show that. I'm going to make a later video about that, how to use the NFS provisioner in such a way. I am now going to use it to show you in this video how to actually use shares. Because most of the time when you're running your own cluster, you know which shares you have and exactly where you want to mount them in your deployment. So that is what I'm going to focus on in this video. Let's get our deployment ready. So let's jump to Visual Studio Code and to our repository. So let's get our deployment ready. I'm going to walk you through the entire deployment so you understand what is going on and what everything means. Now, let's jump to Visual Studio Code. You can find the link to this repository down below, and don't be ashamed, just steal the configuration. It saves you a lot of time, and that's what it was intended for anyways. So let's jump. So this is the repository I'm using. We have used in previous videos before. As you can see, I put myself out of the video so that you can see the files. So this is the NFS. This is the README I was talking about earlier, where you can actually read and find the command to install NFS command for an Ubuntu Linux distribution, which you need to do on all of your nodes. Now, for this repository, we are using a Helm install. Now, so you can also use Helm to give the command to install this separately. We are actually using our GitLab agent as we set up in a previous episode. Go watch it now. Link down below and up here. And as you can see, we have our deployment. We can see we're running here our GitLab helm command, which will run the helm file. And here you can see the NFS helm file is included. Now, let's run to the helm file. This will simply install the repository of the NFS Subdir External Provisioner. We're going to install it into namespace, the version, create namespace, we're going to install it, and our values, our configuration. And if we go to our values, we're going to keep it very simple. We want to have 2 replicas so that if we're rebooting a node, that none of our deployments are affected if they need to move, etc. There's always an NFS provisioner available. You need to configure your NFS server. So here you can see the DNS to my Synology, the path. So I'm actually using Synology Volume 1, K3s, and then the volumes as the default path. And very important, the reclaim policy. So if you're using this NFS provisioner as a provisioner for persistent volume claims on your NFS server, then by setting the reclaim policy to retain, if you delete your volume, it will still remain on your NFS server. You will not lose data. If you set it to the default delete, all data will be gone. So I highly recommend you set it to retain, because it's easier to manually delete the data when you're sure than accidentally have data be deleted. Trust me, I know I lost some recordings with a hard drive crash recently. So, and then this one, the tolerations here, these are optional. So I'm using this, but you're totally fine of commenting this out. Reason for that is that this ensures that the NFS provisioners are not scheduled on my Orion NX, on my NVIDIA node. That's a deliberate choice. Most people don't need this. You can leave it in. It should not affect your deployment at all. So simply leave it, remove it. That's up to you. And the funny thing is, this is it. Now, let's get ready to deploy this. So deploying this just requires you to add it to your own repository, and the GitLab agent will deploy it for you by using the setup I've shown you before. So if you have the GitLab helm file, and then you have configured your NFS provisioner helm file in your helm file list, it will get deployed. You can also do it manually from command line with the helm file command, and I would recommend you go to the helm file documentation how to do so. It's simply going to the directory and then say helm file apply, and it should install. Now, that's it. Let's jump to our cluster. So I actually have it already running because I'm actually using this in production. So I could not show you that it will pop up, but this is what it will look like. You actually can see that there are 2 pods running. And if we go and look, we will see that this one actually says attempting to acquire leader, which means that this one has become the leader and is managing our NFS. So that's it. Now, before we're gonna stop, I'm gonna show you something cool. Because how would you use this in a deployment or in a pod configuration? Now, the easiest way is simply running through it. So we're gonna jump back to our Visual Studio Code, and here you will see a folder test. And in this test, you will see an NFS test YAML. And here you can see how you can actually use your NFS shares in your pod deployment. The same applies to a deployment specification, as long as you put the volumes and the volume amounts on the right location. So in this case, this pod deployment will define a volume, NFS volume, and you simply say NFS server, you give the location of your server, the full path where it can be found on your NFS server, and read only true or false. And this way you can actually mount subdirectories, let's say data, or you have media files you want to mount or anything on your NAS. So this is how you would do it. And then you go to the volume mounts, and here you give the same name as you have defined in the volumes, and you give the mount path within the container. And that's it. And now you can use NFS in your deployments or in your pods in a very simple, easy way. So I hope you enjoyed this video. Like, subscribe down below. Let me know what you think, and I will see you in the next video. I am Garrett, and this is TimmerTech.